Davide Panelli, auch ein Highlight heute, Groovy and Grails.
Okay, good morning everybody. This is the first talk in the morning, so I'll try to keep your eyes open. And what we're going to see in this couple of minutes is just a brief overview of what Groovy and Grails are, because during the last years the web development was heavily based on Java for enterprise level software, and we discovered that this model has some sins, and we can move to a better model of development, especially for web applications. So from a very long distance, Groovy is a dynamic language for the JVM. So it's basically like Java. It's another language that compiles down to bytecode and run on the Java virtual machine. And what is Grails? Well, Grails is a web application framework that is inspired by Ruby on Rails. So from a very distant point of view, this is Groovy and this is Grails. But before I wanted to talk about a bit the original scenes of Java. From my point of view, Java has some shortcomings because it took a ceremony approach. When I talk about a ceremony approach, I think about that the language itself, it's very verbose. You have to write down a lot of things. You have to say public, void, static, main, and you have to write a lot of noise code that doesn't really does anything. It's just ceremony. And from another point of view, from the architectural point of view, Java has pushed a lot of patterns or enterprise patterns. So, for example, I remember a project that there was a web application. It was built with struts, and the action first have to call a facade that implement a specific interface. After this facade, we have a delegate for an EJB remote interface, and after that, when we get to the EJB, we discovered that this EJB was another delegate for a POSIO object. So basically, when we have to change just one parameters of one interface or one function or whatever, we have to modify 4 layers of application, and this 4 layer really does nothing useful for our application. It was just ceremony. And also, Java, during the years, have developed a cumbersome environment. We have fat IDEs, fat application server. Just to start it up together, we need a PC with at least 2 or 3 gigs of memory, because just the IDE takes 1 gigs, and you start the application server for development, and another gigs is gone. So we really have to have a lot of power, and these environments are very expensive in terms of performance. And also we have fragmentation of solutions, and this probably is the most important thing. We don't have a clear way to do one thing in Java. If we want to use our ORM in Java, we can choose between Hibernate, iBatis, and a lot of other frameworks. For the middle tier, we can have a Spring framework, or maybe we can use EGB3 or whatever. So we really have a lot of solution for every layers of our application. And this is basically the effect. to start developing a web application with Java technologies, you really have to know a lot of things. First of all, you have also to ask yourself how my project is structured, because you don't have in Java standard structure. You can build application using Ant, or you can build application using Maven, or maybe you are building application using the facility that your IDE is giving to you. So there is not really one standard project layout. And when you have decided just to build your project, you have also to say, okay, what I'm going to use now. Of course, you can't stay so basic and using just JSP and servlet, because the complexity of the application today is grown too much. So you have, of course, to use a framework to simplify your work. So at this point, from the UE layer, you have a very wide choice. You can really use struts if you are an old-style developer, or you can use Spring MVC, or you can use Tapestry, or you can use DSF, or you can use Seam. There are many frameworks that you can use to develop the UE layer. And this creates big problems, because if you have some developers working on a project, it's not easy for them, even if they are experienced J2E developers, to move to another project. Because basically every layer maybe it's different from what they are using. Maybe they are using Spring Hibernate and Spring MVC, and then the next project is based on Seam, JB3, and whatever. So it's very difficult to move developers around on various projects, because technologies are so different, even if it's all Java. As I said before, Grails was inspired by Ruby on Rails. And why? Well, because Rails proved that we can put some agile into our web development. And which are the main advantages of the Rails approach? Originally, Grails was called Groovy on Rails, but someone from the Rails company have something to say about that, and so the name was changed to Grails. But first of all, Rails is based on a dynamic language, and we will see in the next couple of slides some advantages of a dynamic language. It's much more noisy. You have to write down much less code. Even more, there is an agile development life cycle. You modify something, you reload, and you get it, like PHP or something like that. In Java, you have to compile, deploy, maybe sometimes some Java out-of-memory exception for not deploying. And so it's much more easy to develop incrementally your application. One thing very important is the full stack approach. When you get Rails, you don't get a UE layer framework or a middle tier framework or a database access layer. You get all the stack from the UI to the database. And even more, with Rails, you get also a standard project structure. You get all the Rails projects have the same folders. In each folder, there is the same object, the controller, the model, and so on. Even more, you get also the build system inside. So you don't have to ask yourself, how I build this project? It's Ant something, Maven something. No. There is a standard way, command line tools that you can use to build your Rails projects. Even more, it's based on convention over configuration. Basically, in Java, you have to really configure everything. And so you have to write down a lot of XML or properties files, a lot of things. Instead, Rails take another approach. It says, I have configured this in this standard way. If you want, you can change. But 99% of the time, you don't have to change that thing. So you don't have to bother about configuring every time the same things. And of course, this brings to the main advantage that you can move between Rails project and have no problem moving around that for at least the structure. So now let's start seeing what is Groovy. Well, before just a little history about Groovy. It's not bleeding edge technologies because it's born in 2003, but now has reached a level of maturity that we can use it in our production systems. It's an open source project, it's Apache licensed, and it was standardized even by Sun, so there is JSR 241. So is the second official language for the Java virtual machine. And in 2007 and 2008, there was some business around it. A company was founded and then acquired by Spring Source. But more important is that now Groovy has wide industry adoption. It's used by JBoss, Spring, Oracle, IBM, and SAP, where they use Groovy in their projects. So what is? Some features. Okay, it takes some good ideas from other dynamic language like Python, Ruby, Smalltalk, and it had some interesting metaprogramming features and duck typing. Dynamics it means that is statically checked when you compile your Groovy code. So in Groovy you can really compile a program that calls method that doesn't exist or doesn't exist when you compile, because thanks to the dynamicity of the language, you can add or remove method runtimes to objects, or you can remove them, or you can create them on the fly when you need them. And we'll see an example of that briefly. And even more, it offers some simplification over Java syntax. Well, one interesting thing is about that you take a file that is a .java file, you move it and call it .groovy file, it compiles and it runs. So at worst, if you don't know how to do one thing in Groovy, you can use Java. So, but if you want to move forward, we need to understand that there is optional type. You don't have to put the brackets or some punctuation anymore. Everything is an object. There is no more basic type like int or whatever. There is a special syntax for the posers, the what we call Java beans, getter and setters. They are automatically generated on the fly, and we don't see all that boilerplate code that doesn't really do nothing useful for us. And very handy is the syntax for collections. Collections is one thing that we use every day in Java development, and having syntax for it instead of instantiating a new array list, adding something, removing something, we have much more short syntax. So it's very, very useful to use that. Also, it's introduced back the operator overloading. It was removed from Java, the operator overload, but now we can do, again, overload operators. We have the support for DSLs, which is domain-specific language, and we will see what they are and why they are useful. And we have also closures, and even closure we will see next what it is. This is just a spotlight because we have just 30 minutes, so I can really show you all the powers of the language. But this is a spotlight on collection syntax. So if you are a Java developer, you know that just to do things like that, you need a lot more lines of codes, because to create a list, we have to import the array list, because we have to import that into our file. We have to create a new object, and then we have to add the number 1, the number 2, the number 3. So basically, we really need something about 3 or 4 lines of code for doing just the first line. So as we see, we don't have the type, because in Groovy we can define variables without specifying this type. We can still specify the type, but it's optional. We can just say, okay, this is a variable. Okay, we instantiate and we use 1, 2, 3. This creates a list with 1, 2, and 3 value. Of course, we can navigate the list as it was an array. If we have the standard Java list, we don't have this facility. We can use ranges, because we can specify it from 1 to 2. This means give me a list for the index 1 to 2. We have seen here the operator overloading. So we can add lists together, we can append object to list, we can subtract objects to a list, or even we can multiply lists if we need to. And if we need to iterate, well, it's just a simple syntax as this. Another funny thing is closures. In Java, every running code is included in a class, in a function. Instead, in Groovy, we can define variables that are blocks of code. And we can pass them around as variables and execute them whenever we want. So this is why you can take functions from one object to another and put them together whenever you want and call them whenever you want. Of course, this is a simple, this is a very simple closure that just print a system out, print line hello. In this case, for example, we see how we can declare parameters for our closures. And this time we see another thing that Groovy has. Groovy really enriches all the JDK standard objects. And so we can say 3 times say hello. This is barely English, but it's really running code. And it will print 3 times, obviously, the function that we defined before. And just to say, for example, if you have a list, as we've seen before, you can iterate over it using a special function that is called each, and each object our list is passed into this closure. And so basically here we print every element of our list. Well, they're similar to inner classes, but as you can see, it's much more less code to write and much more simple to use. And this is the fact that all them together, these 2 programs does exactly the same thing. So we can see here that there is, I don't know, a very high number of lines of codes. Instead, we have here just 3 lines of code for doing exactly the same thing. So the basic point is that the reduction of the ceremony that Java introduced, this is a stupid program that just prints out names that have less than 3 characters. But as we can see, in Java there is a really lot of noise that doesn't add any value to our software. The same thing can be expressed in 3 lines of code. So really, this is one of the biggest advantage. If you have to write down half the line of codes, you probably you will use probably half of the times in writing the first time, but it will be very helpful when you have to maintain your code, because every line of code you have must be maintained, and it costs you something. If you have few lines of code, of course, it will cost you less time, and so it's a good advantage for us. DSL. DSL is domain-specific language, which is a small language, not a complete language, that you can define to give domain experts, so to the business analyst to write some business rules for your problems. This is an example of a stupid, if you want, domain-specific language, but this is what you can do. So the programmer just define what these things mean, and someone that is a real expert can write down our recipe. So we can really divide what is technical code from what is business code. You can also do that with Java. You can parse text file and do whatever you want. So you can do these things also with Java. But with Groovy, it's really, really simple, and you don't have to do strange things to do that. So one thing very useful in many projects is to have developers develop technical code and write down a small DSL, and they'll give DSL to the business expert that write down the rules of your system. Of course, Groovy was developed with an eye on the Java world. We can really integrate Groovy in every Java application. So really we have to use the Groovy engine, so we can interpret JavaScripts from inside our Java program. It's just a jar that we have to add to our application. Or we can implement Java interfaces with Groovy, so we can really just provide jar that are really Groovy code to Java programmers, and that we can use it. Okay. So now that we have an idea what is Groovy, we can move to Grails. As we said, it's a full stack Java application, cover from the build system to the UI layer. It offers a set of command line tools to create new projects, to build a project, to test our project, and integrates in any J2E environment, JE environment. It just compiles down to a WAR, and so we can take it and deploy to our application server, and nobody will see the difference between a standard WAR. Well, it's built on Groovy, on Spring, and Hibernate. When we install it and create an application, we create a standard structure of folders where we have inside some folders where we create models, the object on our database, the controller, and the view that are JSP, they're similar to GSP. And also we have services that for the transactional behavior that we want to have, and batch jobs, basically. What is great, as we said, the conventional configuration to call a method on a controller, this is the pattern, and the method is executed. These are simple pogos, so simple plain objects. We can inject into our controllers the services that we need, and the view layer is created by Groovy server pages, which basically are very similar to JSP, but the difference is that it's very easy to create tag libs and reusable components. Whoever of you have ever created a tag libs for JSP knows what's the pain of creating that in Java. And of course, there are a set of standard libraries for logical, UE, Ajax, and whatever. This is just an example. If we just drop a few pogos into the model folders, automatically we have them on the database mapped with Hibernate. So really, this is an example of 3 business domain class where there's an author, book, and publisher. And also there is example for collection mapping. Or if you have already developed your jars with annotation or EJB3 or Hibernate annotation, you can use them. You can import them in your project and use them as Java classes. What we add when we have GORM, the mappers, for example, we have the get, the list, and save all the things that we need to manipulate all these things. And one thing is dynamic finders. Very cool, because for building query, you can simply write book find by title, and you have the query. Or you can mix them, find by title and author. So you can really create query very, very easily. You don't even have to know what SQL is, because you just define query that way. So it's very easy to learn. There is also a plugin system. There are a lot of plugin. You can go here to see all of them, but basically, as you can see, there is a plugin for everything you want, from LDAP, OpenID, or charting, JFree Chart, OpenFlash, or ReachUI if you use GVT or Dojo or whatever. You really have a lot of plugins that do whatever you want. So, just to wrap it up, we have seen that Grails can improve the efficiency of our life cycle, because as Rails, we don't have to redeploy. We can just modify the Groovy codes and reloads, and the things works out. We have to write a less code, because we use a language that is Groovy, that is very much expressive than Java, and it's very easy for a Java guy to learn Groovy and Grails, because it's more or less the same environment. And moreover, you can protect your investment on JE. If your infrastructure is already based on application servers and whatever, you don't have to change your deploy procedures and whatever. And it's based on a rock-solid runtime platform that is Java, because, as we probably know, Rails and the Ruby runtime platform have some problem on performance and scaling and so on. Okay, now I finished, and if you have some questions.
Thank you very much. If you have a question, you can ask him now. You should say who you are and speak into the microphone, so we can record the questions also.
Okay.
Frank Bamali. I have a question. Actually, you say, I mean, it's a convention.
Yep.
But you could have another convention with Java and it would work the same, besides the difference between Groovy and Java, of course.
Yeah.
I mean, if you decide once that you build the web applications, I mean, if you take a Tomcat container, for instance, you won't have the EJB part, you decided you have Hibernate. If you decide this, you have a solid stack which do basically the same, right?
Well, yeah, if you decide, you can decide, of course, your convention, but the problem is that is your convention. It's not the convention that all the world uses, because for Grails or Rails, all over the world, the projects are laid down the same way. This is the difference. In the single project, if you lay down a convention, of course, it's the same thing. But if you have to move developers around different projects or stuff like that, it's very difficult in Java to find a standard way of doing things, because there are so many different architectures, projects. But the reason is also because with this approach, we just started from a whiteboard. Instead, Java, of course, has a long story, so you have to accommodate all the things that come from the history, basically.
But with Groovy, you took a subset of all the Java functionality.
No. You can use just everything using Java. For example, you can call EJB from Grails applications, or you can really just use all Java API. because Groovy is Java. So basically, it's a jar that you put in your Java application. You can start using Groovy. Okay. If you for building a pure Groovy application, there is a Maven plugin, for example. But everything you can do in Java, you can do it in Groovy.
So
Okay, well done.
I have my own also a question.
Okay.
What about the persistence layer? Can I also change this one when I have a persistence layer already with EJB 3.0?
Yeah, well, at the moment it's based on Hibernate and the standard is Hibernate, but for the next version of Grails, for example, you can use any JPA enabled framework, so whatever you want.
Okay, thank you. Thank you very much.
Thank you.